And we're back. We have Dr. Andrea Love. Andrea, thank you for coming on. For people who may not be familiar with you, can you just give us an intro on yourself?
Sure. Yeah. So my name is Andrea Love. I have a PhD in microbiology and immunology. I previously worked in academic research focusing on the immunology of infectious diseases. I now work in biotech. So I'm a biomedical scientist and I work in the field of life sciences where we work to develop therapeutics, interventions, and diagnostic tools for a variety of human diseases, from infectious diseases to cancer to genetic disorders. And then separately, I do science communication through my organization, Immunologic, and tend to be pretty active on social media, and I write a newsletter that the goal is to just get people less scared of science and more interested in, what the data actually say.
Are you working full time in both capacities, or would you say your day job still takes up the most time and you fit in the other stuff?
Yeah, I mean, my day job pays the bills. So that is the one that is my priority. And that's the one that I do every single day. But I would say I spend a substantial chunk of time on, science communication, science education. I'll speak at conferences on that behalf, in addition to speaking at conferences in a scientist capacity. Um, and my partner likes to joke that pretty much all my free time is spent doing science. It doesn't matter whether it's for my real job or for my passion.
Did you always know you wanted to get into the kind of science communication aspect, or did that evolve when you were in academia or when you were transitioning?
No, it's a great question. So I've always had an interest in trying to demystify science topics and get people to realize that science touches everything in our lives, whether they realize it consciously or not. And so, like, I found myself even doing that in high school, and I was really fortunate. My public high school in my hometown, we had some like private funding. It was a kind of a weird situation, but we had some extra science classes that other high schools maybe didn't. So we had a microbiology class, and I took that, and that was after, knowing I was going into that field. But I actually did like a senior project, and it was focused on the importance and a risk benefit analysis of the bacterial meningitis vaccine, the meningococcal vaccine for college students, because there isn't a national mandate for colleges, and college students are at particularly high risk for bacterial meningitis because of the close quarters, and they're not sleeping well, and they're usually not eating that well, and bacterial meningitis can go from seemingly mild symptoms to fatal in a period of a day or less. And so it's a really serious illness that not a lot of people know about. And I wanted to kind of make the case for, like, yeah, it actually probably would lower overall healthcare costs and, improve outcomes if we had this program. So yeah, I've been doing it a lot. And actually, when I was a little kid, my mom she went back to school to get her master's in education, and I went with her to the Eastern Connecticut State University Library, and I picked up a medical textbook. It was called The Physician's Guide to Arthropods of Medical Importance. So it's like critters that spread disease or public health, they're important to public health. And I did judo when I was a child, and so I would walk around at tournaments with this giant textbook, like 8 years old, reading, oh, let me tell you about this bug that eats your flesh while you're sleeping. And everybody thought I was the weirdest person. But and then as I was in college, I actually tutored the student athletes in math and science, and even some, writing courses, because they would miss exams or they would miss lectures because of games or meets, and so they would need to play catch up. And so I realized I had a knack of like communicating things in a way that got it to resonate with other people. And then I, tutored privately to pay bills in grad school. And I also taught clinical microbiology to medical students. And so, I've kind of spoken to different audiences over the years. And I think one thing that's really it's a big gap in scientist training is how to communicate to non-scientists. And so there are many of us who don't have formal training in that, but they have some natural aptitude for it. And so we've kind of stepped into the fray. Um, and I think that there needs to be more emphasis on that, because frequently we see complex topics getting mischaracterized because people who aren't equipped to tackle them are the ones trying to explain it.
Yeah, and the first half of the discussion, I want to dive into some of these topics or areas of health or wellness industry that are commonly promoted, and some of the narratives and your pushback and other researchers and science communicators pushback on them. So we're not going to cover all of them because there's just too many topics, but I want to touch on a few. And then kind of the second half, I want to talk about the behemoth that is some of these wellness podcasts, and how can general population individuals understand how to differentiate what is appropriate scientific communication, and how to differentiate when listening to experts or quote unquote experts. So let's kind of dive into example one of this world of probiotics and gut health. What are these common false claims that you're hearing, or that's commonly being reported on the benefit of probiotics and gut health? I know this can probably go a variety of directions, but what do you think of when you hear of that term, and where is it going potentially wrong?
Yeah, I mean, it's such a shame because, I mean, I remember 15 years ago, the microbiome research was really just starting to emerge. We were having the tools to do these, high throughput sequencing projects where we could take these samples and, look at all of these different species or all of these different genes or all of these different genomes in like a small volume of sample. And we barely had the computing power back then. I remember doing my first microarray analysis, which is a way to kind of look at changes in gene expression across thousands of different genes. And my computer that I had at the time didn't have enough RAM to run the software. So I had to buy a new computer in grad school so that I could run this software. And that was like I think it was like 512 megabytes of RAM, right? So like we've come a long way since then. And it's a shame because when I hear the word gut health now, I almost cringe. I have this visceral reaction where like I hear it and I immediately suspect that there's going to be misinformation. And it bums me out because there's a lot of really interesting and legitimate research coming out about the microbiome, the gastrointestinal tract, the components of the immune system that live in the gastrointestinal tract. There's different compartments. There's a compartment called the GALT, the gut-associated lymphoid tissue, and that's where a lot of immune cells hang out, and that's how they're educated, and that's how they learn to not react to food components. That's where they establish oral tolerance. And they also interact with the microorganisms that live in your GI tract, and that's how they know not to react to them, that they're non-pathogenic. And so there's communication between that, and it's really important, but it's being co-opted by wellness influencers who are using it to sell people false claims and false hope on scientific topics that are not fully characterized. And because they're not fully characterized, they're taking these little nuggets, usually from animal studies or observational studies or really poorly designed, like, there's a couple of intestinal biopsies or some stool samples, and they're making these broad claims that are not supported by the body of evidence. And they're not just benign. I think that's the thing that people don't realize is that, probiotics technically fall under the umbrella of dietary supplements. And in the US, dietary supplements are not regulated for safety or quality or efficacy. And that's because of political legislation back in the 1990s that actually took regulatory oversight away from the safety agencies because they wanted to drive a profitable market of supplements. But probiotics fall into that umbrella. And so people often think, oh, well, they're the good bacteria that live in our gut. And Sort of, but not really, because if you actually look at what's in your gastrointestinal tract, there are trillions and trillions and trillions of bacteria in there. There's 40 trillion bacteria, and most of those are in the large intestine. So you have obviously different components, and you have major classes of different bacteria within these 40 trillion that live in the bacteria in your gut. And there's a lot of them. Bacteria actually make up more than half of the dry mass of feces. So if you had stool samples and you took all the water out, more than half of that would be shed bacterial cells. And they play important roles. We know that. Those are things we know about the microbiome. The microbiome helps us digest food particles that we human cells can't digest thoroughly. For example, bacteria in our GI tract help synthesize a version of vitamin K that is really important. Vitamin K is critical for coagulation of blood. It's also why newborns get a vitamin K shot, because they don't have it when they're born, and blood clotting is very important. But bacteria that eventually colonize our GI tract, they can synthesize a version that we can use. They also help process fiber, and we know fiber is really important for GI health. It reduces the risk of many types of cancers. It improves the regulation of different sorts of circulatory lipids, so your cholesterols and your triglycerides. It also helps with appetite. And so, the microbiome is important, and your gut health is important. The microbiome also helps, as I mentioned, educate our immune system. And, we know that there are all these different proportions of different species. And what people fail to realize is that these are living organisms, and all of these different species, just like humans, are unique and individual. And so some reproduce more because when you eat certain foods, because those are the food types they also like, and others reproduce more when other food types are provided to them. And so all of these studies that look at like changes in the microbiome profiles and things like that, they're not looking at how that actually impacts your health, right? Oftentimes they're looking at these stool samples, or they're looking at, biopsies of people with bowel conditions, and they're saying, oh, well, this person said they ate regular sugar and their microbiome profile's this. And then this other person said that they ate artificial sweeteners and their microbiome profile is this. But this is based on their recollection. There's no like pre-consumption of either thing. And just because you're seeing changes in these living creatures doesn't mean that it's a detrimental change. It also doesn't mean that it stays at those levels, because these are populations that are always dynamic. So it's very complex. And unfortunately, these probiotic companies, they oversimplify it, because they claim that you can take these pills that have these bacteria in them, and that's going to help your GI tract health. And the reality is, there's not really evidence of that. The first thing is that probiotics, you're consuming them, right? And so they have to survive the very acidic environment of your stomach. Unless these things have enteric coatings, that's not going to happen. Most of those things that you eat are going to die. And eventually they have to get to the large intestine, right? So they have to get to the place where they're supposed to be, where those bacteria actually live. And so there's a lot of things that are involved in getting there. When you look at different supplements, they're usually growing, one type of bacteria to maybe, I think the most I've seen is maybe 8 different bacteria in a supplement. And the reason that those bacteria are the way they are is because, they might exist in a sample of your gut microbiome, but the reason that companies are growing those species is because they're easy to grow in a lab, not because they're particularly important to human health. It's because they can make it in large quantities, they can package it, and they can sell it to people. On top of that, as I mentioned, there's 40 trillion bacteria in your gut, right? And so these probiotic supplements, usually they're between 100 million bacteria, maybe a couple 100 billion bacteria. So we're talking orders of magnitude, at least 100-fold lower, sometimes thousands of fold lower than what already lives in your GI tract. So it's a drop in the bucket. It's not going to substantively change the population or augment the population that's in there. And there's a lot of different trials, clinical studies, limited, cohort analyses, looking at whether different types of probiotic supplements, whether they're cookies or drinks or capsules, actually change the diversity of bacteria. And there's really no evidence that they do. And, a lot of people are like, well, I heard like if I take antibiotics and they kind of kill, broad spectrum antibiotics, they'll kill the good bacteria too. And maybe you get diarrhea as a result, which is a function of, the bacteria not being able to do a lot of the absorption stuff. Even in people that have medical conditions, there's really no evidence that especially dietary supplement probiotics offer a benefit. They've looked at, infectious diarrhea among kids. They've looked at antibiotic associated diarrhea. They've even looked at C. diff. So Clostridium difficile is a very persistent bacteria that kind of colonizes once you've wiped out the normal microflora, and it can be really hard to eradicate, and it's often acquired in people who are like in the hospital long term. Basically, they found that there's really no effect of probiotic supplements, particularly looking at things like lactobacillus, which is a very common species. There was like a really small trial amongst kids where they maybe saw a reduction in the duration of infectious diarrhea, but the population was really small and it wasn't able to be replicated. And, essentially it's weak, it's inconsistent, even for these medical issues. And the other thing is that these are living organisms, and there are people that can be at high risk for negative consequences, right? These are bacteria, and just because, we assume that they're all good bacteria because there's no quality control or no regulatory oversight in probiotics, that doesn't mean that they're not contaminated with something pathogenic. Or in people that are immunosuppressed, particularly young children and people on medications that suppress your immune system, even good bacteria can be bad at a certain dose. And so there have actually been some really harmful consequences of probiotic supplements, particularly amongst young children. There were several recent deaths because parents were giving their infants probiotics. So, and this is essentially because the bacteria from the probiotic got into the bloodstream. It created sepsis. Another one was because the product was contaminated with a mold that was pathogenic, and the child died. So, because these are not regulated, there's actually no FDA approved probiotic like medications, therapeutics. So, it's not something to take lightly, particularly because there really isn't evidence that they help.
That was going to be one of my follow-up questions of if an individual is hearing this and they, ask, or they think, what are the downsides? I'm potentially covering my bases. And I think that's a common explanation for a lot of supplementation that people continue to use. But like you said, there are potential downsides, and there's monetary costs, and there's potential really big risks for individuals in certain populations, and the evidence isn't there to suggest it's worth it.
And if the reason you're taking this is because you're like, well, I heard that my gut health is important and the gut microbiome is important. Like, that's true. The gut microbiome is important. Nobody is saying that it's not, but these supplements are really not doing anything to augment it. What does help is these healthy lifestyle patterns, right? Taking in fiber in your diet, eating, a balanced, diverse range of produce items, fruits, vegetables, whole grains, lean proteins, unsaturated fats. And that doesn't mean that you can't indulge and splurge and, eat a cookie, eat a bowl of ice cream, eat a bag of chips. But those are the things that, fuel your microbiome. And so if you were like, okay, well, I want to just take some live microorganisms. Like if the decision is, and you're going to do it anyway, and the decision is taking a probiotic supplement versus a food product that has bacteria in it, like a yogurt or some cheese or a beer, I don't know, whatever, drink a beer if you want a beer. maybe not for breakfast, but yogurt or fermented products, they're also going to have live microorganisms. And the regulatory oversight, at least right now, for food safety is much higher than what it is for dietary supplements. So the concerns about contaminated products are much lower for food products that are going to have live microorganisms than dietary supplements.
Let's transition to the next topic of GMOs. And I guess similar starting point of what are GMOs and why do they have or get such a bad reputation?
So, GMO is an acronym for genetically modified organism. And as a scientist who has worked heavily in cell biology and molecular biology and uses genetic engineering techniques all the time, I hate the phrase. It's completely inaccurate. Technically, every single thing is genetically modified, every organism is genetically modified, but it was created to differentiate. Specifically within agriculture and medical interventions, to differentiate modified organisms that were created through things like hybridization, radiation mutagenesis, chemical mutagenesis versus using genetic tools. And so what a GMO means is it's a hybrid of an organism that has been modified not through selective breeding or exposing seeds to high doses of chemicals to mutate them and seeing what grows, but by using controlled methods where we can transfer specific individual genes that we know confer some advantage and then grow the organism from there. So basically, it's a way of controlling and speeding up the natural process of evolution in a way where we're not affecting all of the genes of an organism. We're just controlling one, maybe two, maybe three, and they're known things. So they came under fire because of influencers and anti-science activists like RFK Jr. He actually started a lot of the anti-GMO sentiment 30 plus years ago. And it's just really been pervasive, and it's been taken up by a lot of non-governmental organizations that appear to be like environmentalists, like Greenpeace and the Environmental Working Group, but in reality, they often have very heavy anti-science sentiments. And the belief has really stemmed from just wild mischaracterization of what they are. So if you mention GMOs to somebody who's like just tangentially familiar with the term, they often immediately say, oh, glyphosate, right? And that's like one tiny little fraction of the story. So when we think about GMOs in the context of agriculture, these are crops that have been modified using these genetic engineering tools to have some sort of benefit. So for example, we have the Hawaiian papaya has been GMO'd to resist the papaya ring spot virus, because when that infected papaya trees in Hawaii, it wiped out the papaya population. It was like 90% of the papayas died because of this virus. And so scientists engineered a version of the Hawaiian papaya that resists the virus. And so they were able to replant and repopulate all of the papaya farms on Hawaii and recover that entire species, essentially. And so anytime you buy a Hawaiian papaya, it's a GMO. People don't realize that. And so GMOs have really been demonized because even the one that they're referring to, these glyphosate, these herbicide tolerant GMOs, have been painted as a villain because they're conflated with a chemical company, Monsanto. I'm sure you've heard of it. It doesn't exist anymore. Monsanto made all sorts of chemicals over the history of its lifetime. And, the story is just kind of a coalescence of conflating things and low science literacy and fear mongering and telling people that their DNA is going to change if they eat a GMO. And, when you digest food, every food has DNA in it, and your stomach acid digests it exactly the same way. It makes no difference whatsoever. But in the context of, say the glyphosate, these were plants that we swapped an enzyme in. So plants have to make their own amino acids, whereas humans, we eat amino acids and we can synthesize a few of them. And so plants have this enzyme called EPSPS, and it synthesizes a few specific amino acids that they need to survive, because amino acids make proteins and plants also have proteins. And so these, make the structure of the stalk of the plant and allows it to grow and so on. So when we're talking about farming, there's things that are trying to kill your crops all the time, right? And if the crops are killed, you can't have food, right? You can't grow the crops. And these range from viruses and pathogens and fungi and insects and rodents and weeds, right? Other plants. Other plants will grow and they'll, crowd out nutrients and they'll starve the crops that you actually want to grow. And so farmers have to use different methods to control these different things that are trying to kill their crops, which end up being food for you. And so we have to use herbicides, right? And herbicides kill plants. And so historically, they had to use many different herbicides, because you want to make sure that you're not killing your actual crop, right? They have to be selective. And so you've got an herbicide that's going to target like broadleaf weeds, and you're going to have another one that's going to target your grassy weeds. And so you have all these different combinations of herbicides, and you have to apply them in different, parameters in order to kill the weeds, but not kill your crop, right? So they were able to essentially eliminate all of that and reduce how much total pesticides they could use, how much total herbicides they could use by taking this enzyme that makes these amino acids. Normally, if you expose a plant to this chemical glyphosate with that enzyme, the glyphosate inhibits the enzyme, it can't make amino acids, the plant wilts and dies. But what they did was they swapped that enzyme for a bacterial version of the enzyme that glyphosate didn't interact with and it didn't interfere with. And so in the presence of the glyphosate, the plant wouldn't die and you could continue to grow it. But all the weeds that didn't have the bacterial enzyme, they had the plant one, they would die. So now you've taken all of these multiple herbicides and you've reduced it to just this one herbicide that you needed to use. And so these are called herbicide tolerant crops. And they're advantageous because now you don't need to apply multiple chemicals. You don't need to till the soil, which leads to runoff and soil erosion and leaching of nutrients. And glyphosate is actually much, much, much safer than all of those other herbicides that previously were used. So we've actually been able to drop down how much of those we need to use for these specific crops that have this tolerance. But of course, then RFK Jr. actually started a conspiracy because he had these people lined up and he was a lawyer, and he actually started the lie that glyphosate caused cancer. And it was because he had a really big payday coming out from these lawsuits. And that's actually what his entire career is built on, is making frivolous lawsuits and convincing, making these public arguments that convince a jury or are outrageous enough that they're either going to rule in favor, because it's not about data, it's about who makes the most convincing argument, who makes the most emotional argument, or settlements happen because it's just, it's easier, right? So he actually started this because, again, to get these lawsuits flowing, you had to erode trust in this modern agriculture technology. So we have over 30 years of data. 20 plus safety agencies globally have reaffirmed the safety of glyphosate, specifically have reaffirmed that it's not causing cancer, it's not linked to cancer, it's actually used in very, very small quantities, but these myths really persist. But GMOs are way more than that, right? Like I said, the Hawaiian papaya, there's a GMO called golden rice, and it's rice that has a vitamin A precursor, beta carotene, and vitamin A deficiency in developing nations causes pediatric blindness and death. And rice is a subsistence crop in many of these countries. And so going from rice that has no vitamin A to rice that does have vitamin A, that could save lives. And it was approved by the Philippines a few years back, but now it's being blocked by a judge in a court because of misinformation. And so the reality is that GE crops, genetically engineered crops, GMOs, they have a lot of benefits, but they've really been painted as a villain and conflated with pesticides when GMOs actually have allowed us to reduce the amount of pesticides we need to use on crop fields by over 9% in the last 20 years. So if you are talking to people about and they're concerned about pesticide use, but they're opposed to GMOs, it's actually contradictory because GMOs, we can impart natural pest resistance into these crops, and then you don't need to treat them with other chemicals. And so there's a lot of ecological benefits. They can improve food yields, so you can address food scarcity in non-affluent places, food deserts, developing nations. Many of these are completely off patent and they're donated to developing countries. There's a version of an eggplant that's been donated to Africa that is resistant to insect pests, and it's going to be incredibly beneficial. But there's a lot of opposition to things that people don't understand, especially when it comes to complex biotechnology. And so it's a problem because the same exact technique that we use to like impart these genes into plant cells, we do to make cancer treatments like CAR T therapies. And it's the same genetic engineering process. It's just engineering your immune system versus engineering a plant. And so I have a lot of concern that the continued opposition and people's just unwillingness to even try to learn what it is going to transfer into these life-saving medical treatments too.
Yeah, to that opposition and to some of that like reversal of things that were beneficial and now it's making it harder. You mentioned RFK Jr. I think you had posted recently, there was like, was it a health council or something? And it had him and there was a few other interesting characters. And that I guess just goes to show how much influence they can have also on kind of a legal political level.
Yeah, absolutely. And it's really interesting because, you know, a lot of times when we're trying to kind of address misinformation, there's this common argument, well, it's banned in this country or this country hasn't approved it or this country. And I think people, and I would encourage everyone to take a refresher on governmental structure and function, just some schoolhouse rock, because people do not realize how policies and laws happen, how regulatory agencies are funded, how much budget they're going to have to do their jobs, to hire personnel. So you can have all of the science in the world saying that XYZ is safe, XYZ is beneficial, you know, golden rice is going to save lives in these developing nations that don't have access to staple foods that contain beta carotene like carrots. But if there's public outcry and if the court of public opinion and enough constituents scream at a politician or scream at a judge or have a petition that they're going to scream at Kellogg's, you know, that impacts policy, that impacts the lawmakers, which are not the scientists, right? The lawmakers are the politicians that are signing off on these things. And often the budget is being decided by the legislative branch, like Congress. And so it doesn't even matter, you know, what say in a state, what the governor says or what the president says in a country. And a lot of it comes down to these politicians are influenced by their own biases. Maybe they're influenced by money. Maybe they're influenced by misinformation. But just because they should be using science to make decisions and make policy doesn't mean they are using science.
Let's transition to the last topic within this little first half, avoiding vaccines or hesitancy with utilizing vaccines. This is a huge one. What are some of the common narratives? And I know it's kind of exploded since COVID, but wherever you want to take this topic.
Yeah. So, you know, there's a lot of themes that we see with anti-vaccine sentiment. So, you know, first, let me just say that, you know, there are people with legitimate concerns, you know, legitimate questions. They maybe were exposed to misinformation and they really just kind of need to be led to the right sources. We're not going to talk about those people because those are people who are actually looking to learn. We're talking about the people that are staunchly anti-vaccine and who actually participate in the dissemination of falsehoods about it. So It goes everything from vaccines are causing some harm to your health. So started with autism, and that was because a completely fabricated paper by a guy named Andrew Wakefield, who now lives in Texas, lost his medical license. He falsified data because he wanted to file a lawsuit, make a lot of money. He wanted to sell his own vaccine, make a lot of money. He wanted to create a fake autism diagnostic kit, sell that, make a lot of money. And he literally just lied, and it got published, and it took 12 years for it to get retracted, even though there's millions and millions of data points that demonstrate there's no link to any vaccine and autism. The link with autism is primarily genetic. So if you have a sibling who has autism, you have a high likelihood that you might have autism. But so there's that. So there's health impacts, and now it's not just autism. It's, oh, they cause autoimmunity, they cause cancer, they do this, they do that. So there's, you know, using health anxiety to scare people away from vaccines. So there's that one. There's also like the chemophobia, which is really based on low science literacy, that vaccines contain all these harmful chemicals. Again, these are wildly mischaracterized. They're talking about things that you're exposed to at much higher levels on a day-to-day basis, like aluminum salts, which are everywhere in our environment. You eat 7 to 9 milligrams of aluminum every single day. Aluminum is used in very specific vaccines as a salt. So it's not just like metal aluminum put in there. It's a salt, like table salt is a sodium salt. So it's a ionic compound. It's used because it serves as an adjuvant, meaning it can augment the immune response without having to add more of the active ingredient of the vaccine. It's used in very small quantities in very specific vaccines. Then you have people who just misunderstand basic chemistry, and there was a whole misinformation campaign about a compound called thimerosal, which was used as a preservative. So basically, it prevents contamination of vaccines, which is a good thing because we just talked about probiotics being contaminated and killing people. We don't want our vaccines contaminated. And so it's a derivative of a version of mercury called ethyl mercury, which is actually a pretty non-toxic compound, and it's rapidly excreted from your body. But people confused it with elemental mercury, which is that silvery liquid that was in the thermometers, or methyl mercury, which is the version that accumulates in the environment and in fish like tuna. And those two can be toxic at relatively low doses and do accumulate. So not the same thing, but got painted with the brush, often intentionally by people like RFK Jr. Then you have kind of the I don't want to be told what to do. I don't want the government controlling me. Therefore, if anybody says that there's going to be some sort of policy or mandate, I'm going to refuse that. And that's not constitutional, even though like hundreds of years ago, the Supreme Court actually ruled that vaccines in the greater good of public health are constitutional because people didn't want to get smallpox vaccines and, you know. So those are like big buckets. Then you have the other kind of more insidious, like, oh, well, we're harming our immune system. We're overwhelming our immune system with too many vaccines at once, or natural immunity is better than vaccine immunity. And these are really, some of it is based on just the immune system is very complex and people don't understand it well, but none of them are actually based in reality. And the reason that they're so pervasive is because our society has benefited from vaccines. We have survivorship bias. Many of us have not seen someone with these deadly and debilitating diseases, particularly the ones that have disfigurement, like smallpox, like polio. So we've really benefited from that. But, you know, like I've been to a lot of developing nations, and they would bend over backwards for vaccines, you know, to be freely and widely available. And so, you know, there's a degree of privilege here, where people, you know, they don't remember these things being a big deal, and therefore they don't see the reason to continue these measures. But the reason they're not a big deal is because we're controlling them with vaccines. And if you stop vaccinating, then they're going to come back. And that's what we're seeing with measles and with pertussis, whooping cough. There's a huge outbreak of that because people are not getting vaccinated. You know, we saw a record number of pediatric flu deaths last year because people are not getting vaccinated. And so, you know, people like to talk about chronic illness and chronic disease, cancer and neurodegenerative and so on. And the reason that we're dying of those things now is because we're not dying younger of acute infections. We've shifted our cause of death to things that develop as we age, as opposed to many, many, many of us dying before our life expectancy ends. And so, there's just this lack of context when we talk about these things, and it's very concerning, because these things don't exist in a vacuum. We have a lot of people who are like, well, I should have the freedom to make my own decision, but you live in a society with other people, and these diseases are passed person to person, so your decisions impact all of the people you interact with, and I think that's something that a lot of Americans don't value.
So you have this big reach in regards to discussing these topics on kind of a mass scale on videos, podcasts, your own platforms. But within the day-to-day, the healthcare professional that has to have these interactions with patients and try to discuss some of these beliefs that they may have or questions that they may have around any of these topics, whether it's vaccines or their request for specific therapy that may not have any supporting evidence, or hesitancy with therapies that do. Do you have, on the kind of individual level, recommendations for providers to have meaningful and beneficial conversations with patients to potentially shift them in a more helpful position?
Yeah, it's I think that's the $1,000,000 question, and I think, there's a lot of people, I think, that are receptive to new information. And so, as a provider, the first thing is to really understand where they're coming from, right? Because the resistance or the propensity for something is motivated by something, and it's usually not a logical something, right? It's some sort of emotional driver that they have trust in a certain person. They formed a parasocial relationship with an influencer, and that person is telling them that thing, or they've been scared by something. Fear and anxiety and worry are huge motivators. And so the first thing is ask them to help you understand why you feel the way you feel. And when you open the door that way, they're often going to volunteer information that maybe you wouldn't have gotten otherwise. And they're typically going to be more receptive to hearing your response to it, because you've started the conversation with, tell me why you feel that way, right? What's bringing you to that place? And then from there, you want to acknowledge, okay, I understand, because you've been told vaccines cause cancer. That's really scary. I wouldn't want to take something that causes cancer. That sounds awful, right? And then it's, okay, I understand why you feel that way, and let me explain to you why you don't need to feel that way. And so this kind of rapport, this trust, is super important when you are looking at what gets buy-in from people. Because I recently was presenting about improving participation in clinical trials for minority groups, and the biggest determining factor to get underserved or underrepresented communities in clinical trial participation is having people on the clinical research team that are like them. So if we're saying Hispanic people, well, you need Hispanic clinical research members, because they're going to automatically feel more trusting of someone they relate to than they're all strangers, right? But someone that they feel like they can relate to more than a stranger that has nothing in common with them. So that trust building is really important. And also you have to remember, I'm a scientist. I want to just always talk about data, because that's what tells the story. But people need an emotional connection in order to believe the story. And so you also have to remember that a lot of times they're leading with feelings and not facts. And so often, if you have an anecdote to get them to be emotionally receptive to the actual information, that can also help create that trust. So a lot of that really plays into who do they feel comfortable believing when they're presented with information? And I think that's something that the providers can play a really big role in.
With the time remaining, I want to switch gears to this wild wellness, fitness, health influencer podcast situation. So yeah, the biggest one I think people think of is Huberman. but there's so many. And I want you to at least, or to start touching on, how did these podcasts get so big, and what are some of the common themes of the people that are brought on, and these experts, quote unquote, that are brought on? What are things that they're saying or doing that is making these such big audiences interested in them? And then how can the person that's listening have more of a critical view on these episodes and on these guests and podcasts?
Yeah. So I think the reason that they've grown as much as they've grown is a couple of factors. The first is the wellness industry and the lack of regulation on supplements and so on. So that really started in the 90s, but it exploded in recent years. But it actually was born earlier than that with this idea of medical freedom, and it actually coincided with the development of like the organic food industry, which is really just a marketing label, and also coincided with the anti-vaccine movement. So you have this very interesting convergence of all of these kind of anti-science. They look like health on the surface, this health-ism, but they're actually born out of anti-science and a push toward a deregulated marketplace where people can just sell whatever they want with no repercussions, with no oversight. And so that has exploded recently, in part because of the new media ecosystem, where media used to be print media or magazine media or media websites, and they were very driven by like specific advertisers. Now it's subscriber based, and people are monetizing social media, and people have a shorter attention span. And so media outlets are now also mischaracterizing science to get clicks. So it's all very clickbait driven. And it's, oh, this study says you're going to get cancer from these spatulas, or you're going to get cancer from this. That's not what the study said. And it's also not representative of the thousands of other studies in that topic, but that gets people's attention. And so people now have this anxiety. They're paralyzed with health anxiety. And it's this fear economy because fear is profitable. And now the podcast space has essentially replaced the old talk radio with these long form podcasts. I remember the first time I listened to a Huberman episode because I was debunking the lies. I was like, this is like Rush Limbaugh. Like, you just have it on in the background. It's just going and going and going and going and never ending. And that's exactly what his podcast is. That's what the Rogan podcast is. That's what Lugavere, like all of these like manosphere, bro, biohacker, techie, whatever. And it's very lucrative because it's long form. So they got a lot of sponsors, and there are a lot of wellness companies because you've got the media who's created this health anxiety and this fear economy, and everything is killing you and everything is toxic, and they're wildly mischaracterizing science concept because they're using the wrong experts. They're using a psychiatrist instead of a toxicologist, or they're using a dermatologist instead of a chemist. So then the wellness industry is profiting off of that, right? So they're like, oh, well, everything's toxic. Everything is giving you cancer. Well, if you want to take control of your health, here's your immune booster. Here's your longevity thing. Here's your sleep aid. Here's your cortisol stress reducer. Here's your hormone supplement. And so it exploits the health anxiety and the fear economy, and then it sells them this false promise that you can hack your health and take control of your health using all of these products that they're selling. And so they use the jargon, right? The science podcasters, they use terms that sound technical if you are not a scientist, but they're either misused or they're just like slapped together. I remember I was listening to his cold and flu episode, and he just listed a bunch of random proteins that are not related to each other at all to sound science-y. And he'll even say, oh, well, this science backed, I'm telling you the data. But there's a degree of quality of science, right? So a lot of these wellness companies use things like backed by evidence or clinical data or science supported. But if you actually look at the science they're using, it's an animal study or it's a petri dish study. So you're growing cells in a piece of plastic, and that's not what happens in a person. But yeah, technically it's science backed because there's one study out there that shows this really nebulous thing, but that's not what we say when we're saying there's evidence to support something. But because these things are so long, nobody has the time to go and fact check every single paper that they're claiming is science backed. And so the big things that you want to look for is that, are they making things sound too easy, quick fixes, magic solutions, they're simple protocols, low cost protocols, this, that, and the other, all these sorts of things, too good to be true claims, making really broad statements about, health and singular interventions that are either going to make or break your health, right? Mouth breathing is not going to harm the amount of nitric oxide you produce, and it's not going to impact your immune system. So those sorts of things, if they're speaking well outside their expertise, that's obviously also a big red flag. But generally speaking, I think people need to view these podcasts not as science and not as scientific education, but as entertainment, because there is no oversight. It's essentially a radio show with video, right? And just because this person has maybe a related degree doesn't mean that what they're saying is factual, right? You have to remember that they're trying to drive listeners. So they're going to say things that sound really clever, sound really appealing, sound like, oh, well, he's going to help me improve my life. He's going to help me improve my health. He's going to help me live better and develop better relationships and do this. And so everybody likes the appeal of improving themselves. But that's usually a lot of hard work. It's not these quick fixes and these simple hacks. And you have to remember that these people are making a lot of money off of their listenership, off of their sponsor deals. And it's not peer reviewed. It's not subject to the scrutiny of the scientific community. And so they can say whatever they want. And once the horse is out of the barn, it's so much harder to go back and undo it, especially when they get platformed by other celebrities that amplify and give them more attention. So like my general, assessment is, if you enjoy listening to these podcasts, do you, I guess. But remember that you're putting money in their pocket and they're exploiting people and actually doing a lot of harm. We're seeing really, really high increases in acute organ damage because of herbal supplements and dietary supplements. I have a friend that was just at a hepatology conference, which is liver science. And yeah, in the last 20 years, like really, really increased rates of acute liver damage because of dietary supplements. So it's not benign. But if you really want to listen to it, like you just need to approach it with, you can't assume that what they're saying is true. You can view it as entertainment, but you should not be taking advice on how to change your life based on someone that's talking to you, on a podcast.
Whether it's your information or your resources or others, do you have better pathways or avenues for the general population to seek out more reputable information?
Oh man, it's such a challenge because I feel like, people have this perception that everyone can be an expert in all things, and that's absolutely not true. And particularly in science and in medicine. And so, if you see healthcare providers who are talking on complex science topics, you have to remember that they're not automatically scientists. And the same, if a scientist is trying to provide clinical treatment, like that's also not a good thing. But even within those fields, like there's subject matter expertise, right? So one of the things is that if they're talking about topics that, they have no path to having an understanding of, that should be a red flag. And you should always seek out a relevant expert on that given topic and understand that means you're going to have a lot of different people that you're going to look to for information. But it's kind of a shame because I've seen people who have been pretty evidence-based within like their fields, but now they're also platforming misinformation and pseudoscience because we have this media ecosystem as like the following grows, the ego grows, the sponsorships offers grow. So like if someone is selling something, that's usually also a red flag. And a lot of these people that take on sponsorships or, have these paid partnerships, it doesn't automatically preclude their information from being accurate, but you kind of want to take it with a grain of salt and say, hey, is this supported by, all of these other agencies? Typically, our governmental safety agencies and scientific agencies are reputable, but I know a lot of people are distrusting of that. So, if you say, oh, I don't want to trust the CDC, well, what about, the European, infectious disease or, European medicines agency? We have global entities, right, that provide information. So usually, what I recommend is look to authority agencies, and I don't mean medical professional organizations because those are just like a cohort of people, but like the actual scientific agencies, and like at least cross reference two or more, because again, even some of them, depending on the topic, can also spread, not full truths. But yeah, I mean, I feel for everybody because it's super frustrating. And I am always really wary to even recommend single people to follow, because then I take some ownership of, if that person starts to stray, well, now I've told that person that they're credible, but now they're speaking on topics that they shouldn't be speaking on. So I would say, like, if you develop a trust with someone and they're staying in their scope and they're always providing resources that are backed by large groups of data, not single studies that are picked out and selected to kind of push a narrative, I would say you could rely on that person for content on that topic, right? So there's some really good cosmetic chemists that talk about misinformation about skincare, or there's toxicologists talk about misinformation about like people extrapolating tiny doses of things being toxic. And so like, looking for people that kind of stay siloed and aren't making these really broad statements about topics that they shouldn't be speaking on, and especially if what they're saying about those topics is because of outliers, right? And again, the guests that people bring on are usually a reflection of that, right? If they're a contrarian in their field, just because they're in the field doesn't mean that they can't be the outlier. And frequently you see that, oh, well, Huberman brought on Sarah Gottfried as his hormone expert, and she pushes the false narrative that you can hack your hormones with diet, and she sells books based on that premise. And her mentor is one of the OG anti-vaxxers, Christiane Northrup. I mean, that was selected intentionally because she is a contrarian. But because he can say, oh, well, she's a women's health, whatever, like people are like, oh, well, she must be an expert because he picked her. But it's the same tactic. It's undermining the 99% of experts in that field by bringing on the 1% that actually do the harm and spread the misinformation.
I know you have to go, so I want to respect your time, but this was amazing. We'll link your information and more of these kind of conversations that you've had in the show notes. Thank you so much, Andrea.
Yeah, thanks for having me, Chris.